What's up, Algebra 1? So today we're continuing to talk about sequences, both arithmetic and geometric, but now we're kind of adding in that there's two different types of formulas for each of those, which we call recursive and explicit. So let's jump into it. So the first thing it says, explain the difference between a recursive formula and an explicit formula. So the main idea for the difference between these is, do you only want the next term, which is recursive, or do you want to jump to some future term? So if I say, here's a sequence of numbers right here, and I say, well, there's the first number, the second number, the third number, the fourth number. Well, I want the 100th number, okay? And that's not necessarily the next term. I want to jump into the future without having to list out the other 96 terms in the middle. That is the main idea for the difference between these, okay? Sorry. So let's go back. So number 1 says, Greta must volunteer 225 hours for a community service project. She's planning on volunteering 6 hours each week, and after 3 weeks have passed, she's already down a few. So she started with the 225 hours required. She did 6 hours of volunteering, so it went down. She has only 219 hours to volunteer. Then she only has 213 hours to volunteer, and then 207. And so eventually she's done. And so most people are curious as to, if I'm doing 6 hours a week, how many weeks would it take until I'm done? Which is a pretty reasonable concept for people that are thinking about this type of problem. So A says describe this sequence, and I went ahead and said, well, it's arithmetic. It's subtracting. Adding or subtracting is the concept of arithmetic. So for this one, it's subtracting 6. So that means my common difference for this problem would be -6. But it's now saying use a formula to determine how many hours she has left to fulfill her requirement after 33 weeks have passed. So today we talked about how to build those formulas. So I'm going to step down for a second for part B. It basically says, what is the first term? What is the first term? That's this A sub 1 idea. The first number is 225. What is the common difference? Okay, common difference for that problem is -6, going down 6 hours every time she volunteers. And we're curious, after 33 weeks, how much she has left. How many hours does she have left to do? And so if we were to calculate this comes out to be 33. She would have 33 hours left after 33 weeks. So if you just do 225 minus 6 times 32, that's where you're going to see that 33 hours. So I kind of did C and D together here. It says, which formula should you use to determine how many volunteer hours she has left after 40 weeks? So what I did first is I said, let's come up with the formula. What is the formula that I can just plug in the number of weeks and it just tells me how many hours I have left? So we kind of started out similar to the first part B. But if you notice, the only main difference is when I got to N, I didn't replace it because I really don't know what that number is. I know we're going to use 40 here in a second. But in general, it's saying which formula would you use. So I'm trying to build a formula that has a place where I can plug in a number. And so I distributed -6 times n, negative times a negative, +6. And then just moving down a little bit, that simplifies down to be this equation. Okay? -6n plus 231. So now, if I'm curious, well, 40 weeks, let's plug in 40. And if you notice, I've got a negative number. And so what does that mean? Well, that basically means she has done too many. I don't need to continue to come volunteer. She is good to stop if she wants to, because that negative means she has exceeded the requirement of the original 225. She's actually done 9 hours more. Okay? So those numbers are going down until you get to 0. Anything past that, you've exceeded the work requirement. So that was an arithmetic one. Geometric is when you see more of a concept of multiplying or dividing. And so you're talking about half-life. This is very common in physics, chemistry, a lot of science classes, even pre-calculus. We talk a lot about half-life. And so all these substances that we've found on our world, basically over time, so much time goes by and now you have half of the amount, okay? So let's say you started off with 1 ounce of gold or 1 ounce of carbon or whatever. There's so much time that goes by that basically it diminishes, it decays, and now there's half of it there. And then half of that, you're at a fourth, and then half of a fourth, you're at an eighth. And so this is now asking me to describe the sequence. And so I'm saying it's geometric, it's multiplying by 2, or sorry, no, it's multiplying by a half. It kind of feels like I'm dividing by 2, but multiplying by a half is essentially the exact same thing. So we're going to use that fraction here in a minute to represent our equation. So part B says calculate how much of the substance will be left after 21 half-lives, when you've halved it 21 times. So it says, show your work, does your answer make sense? So I came over here and I said, well, the first number is 1. The concept is you are halving, so the R value is 1/2. And then the exponent is where I can place what term I'm looking for, and that's n minus 1. So on the right side, I went ahead and plugged in the 21, and it looks like my answer is 9.5 times 10 to the negative 7. So I'm kind of relying on, maybe you've seen scientific notation before. This basically means how many times I'm either moving that decimal to the left or the right. And so I am moving that decimal 7 times to the left to get this decimal value that's really tiny. Doesn't make the number negative, just makes it super small. Scientific notation is a way of writing really big or really small numbers really in a few strokes. So 9.5 times 10 to the negative 7, that's much faster to write than this actual number, which is very small, 0.00000095. Now, one thing that I've kind of developed, that negative 7, 1, 2, 3, 4, 5, 6, 7, that kind of tells you how many zeros there are. You do have to know that that decimal point kind of falls between the first two, but that has really helped me speed up my scientific notation concepts. Let's stretch that a little bit. Consider the first two terms of a sequence. They give us two fractions, 1/16 and negative 3/16. So what I've done is I've taken a moment to say, if it's arithmetic, what would the common difference be? So I subtracted the second one from the first one. And if you do that, they have a common denominator. So negative 3/16 minus 1/16. Those numbers in the top, the numerators, go together to give you negative 4/16, which is really just negative 1/4. So you can either think of it as negative 1/4 or the decimal of negative 0.25. So I'm using that to do the first one. Using that same formula we were doing a minute ago, the first number plus the common difference times n minus 1, I'm trying to get a formula for calculating whatever term I want in the future. And that is explicit formula is what I'm going for. So I said the first number is 1/16, and the common difference is negative 1/4, and then the n minus 1, you see me distribute, and I combine all of my like terms until I get a very simplified equation right here, okay? So once I have that explicit formula, I can then answer the question, what is the 63rd term? So let me scroll down a little bit. I'm plugging in 63 for the n value over here, and all of that math comes out to be negative 15.4375. I also pressed math enter, had my calculator convert that decimal into a simplified fraction. It is improper, but that could be an alternative way of answering it on an assessment. The second part kind of asks, well, what if you were asked to find the 63rd term, knowing that it was a geometric sequence? From last night's homework, we talked about how given just two numbers, you really can't tell if it's arithmetic or geometric. So in this question, they're kind of having you explore both possibilities. So what I did is in the top right corner, I went ahead and said, well, if we're really talking about geometric, well, I need to calculate that common ratio. And if you divide the second number by the first number, negative 3/16 divided by 1/16 actually comes out to be really nice as negative 3. So when I'm thinking about their formula, I've got my first number, a sub 1, which is 1 over 16. And then I've got my common ratio value, which is -3. I've got my formula fairly quickly. There's not a lot of simplification that's necessary. But I am using that formula to calculate the 63rd term. So now I'm plugging in that 63 in for the n value. And gosh, this is such a crazy answer, and that's why they want you to write it in scientific notation. So I got that my 63rd term is 2.38 times 10 to the 28. Now my calculator didn't actually say that in exactly. It said 2.38 e 28. So the e is really both the times and the 10. Okay, that e represents knowing that you're saying times 10. That 28 that follows is the exponent of 10. Okay, so you may be wondering, what is that? Well, that's this number. That is, instead of that decimal being 2.3, I've moved it to the right 28 times. So you can see that that is a very, very, very large number. Okay, so when we see scientific notation with a very big positive number, that means that number is really, really large. Versus, if we said this number was a -28, well, that means I'm moving the decimal to the left, meaning I've made a really, 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 really small number. Okay, 0.000000023 or whatever. Just to kind of review scientific notation for just a moment with you guys. I'm not going to do too much on the back. This is review, so I'm slowly just kind of taking away the support, making sure that you understand the things that we've already kind of done in the class. So let's check this tomorrow. Determine whether each given sequence is arithmetic or geometric. So you're going to either write arithmetic or geometric on the first one along with the second one. These are two separate problems. Once you determine if it's arithmetic or geometric, go ahead and tell me the next 3 terms in both of these. Remember that arithmetic means you're adding or subtracting consistently. That is the common difference between each number, versus geometric common ratio, which means you are multiplying by something to get to the next number. Number 2, going back to the very first lesson, determine which one is independent, which one is dependent. So independent is the x-axis. That y value depends on the x value. So go ahead and go in there and just tell me which one is independent, which one's dependent. That would be awesome. Okay. Number 3, determine which function family the equations would fall under. So really study the heart of the equation. Tell me which word best goes with that particular problem. Same thing here. Look for the x, what's going on with the variable. And just go ahead and tell me which word you think makes the most sense for that particular equation. I hope this has been helpful. We'll see you guys tomorrow.